Welcome geniuses, I'm Genie, your best buddy for A-levels. In this channel, we'll bring you to explore the secret formula behind success.
Hi, this lesson is about representation of data. In the previous lessons, we talked about summarized data. So this lesson, we will look at the combined sets of data, and we focus on finding the mean and the standard deviations of two sets of data. So when we find the mean of one set of data, the formula is given as x bar equals to sigma x over n, and the standard deviation is given by square root sigma x squared over n minus the mean squared. All right, so the formulas are similar. In order to find out the mean of x and y, two different sets of data together, we look for the sigma of x, the total of x, plus the total of y, then divided by the total sample size of both x and y. So similar, the standard deviation of x and y is going to be the square root of sigma x squared, sum up with sigma y squared, and divided by the total of them, and minus of the mean. So can you see, this is actually the mean of x and y. All right, let's have a look at the example 1. Okay, 25 values of x are such that sigma x is given and sigma x squared is given as well. And 25 values of y are such that sigma y is 387 and sigma y squared 6114. Okay, calculate the variance of the 50 values of x and y together. So in order to find out the variance, what are we supposed to do? Okay, we know that if we find the square root of variance, we get the standard deviations. So in order to find out the variance, we do not have to square root it. So according to the formula we have, so let me write it down. Minus the mean of the x and y, right? So with sigma of x plus sigma of y divided by the total of the sample size, bracket and square. Right? With all the info given, we should be able to get the variance of these 50 values. So sigma x squared given by the questions, 6006. Sigma y squared, 6114. All right, divided by sample size of the x, 25. So 25 here. And there are 25 values of y as well. So 25. So minus the mean of the x and y total. So we have sigma x 388 and sigma y 387 divided by 25 plus 25. Total sample size of x and y and v squared. All right, so we can now use calculator and to find out the values of the variance, which is going to be 2.15, right? Now let's look at the past year questions. Okay, this is the questions from May-June 2011, variance 63, question 1. Brick Street Garage has 9 used cars for sales. Fairview Garage has 15 used cars for sales. Okay, so we write down the info, Rake Street. So we have the sample size for the cars from Rake Street. I use capital R to represent the Rake Street, has 9. And the Fairview. So the sample size for Fairview has 15 used car, 15, right? Capital F stands for the Fairview Garage. So the mean age of the cars in Rake Street Garage is 3.6 years. So we have the mean of the Rake Street Garage. The mean age of these 9 cars given to be 3.6. And the standard deviation is 1.925. So the standard deviation, let's say I'm using sigma to represent the standard deviation for the Rake Street Garage, and the standard deviation is 1.925. Okay, in Fairview Garage, so somehow the Fairview Garage information given are different. So sigma x for the Fairview Garage is given to be 64, and the sigma x squared for the Fairview Garage is given to be 352. Okay, where x is the age of the car in years. Okay, part 1, find the mean age of all 24 cars, right? 9 plus 15 is going to be 24. So according to the formula we have, we are looking for the total mean age of all 24 cars. So in order to get that, let's first find out the sum of the Rake Street used cars, the ages. So we have the formula, Rake Street, and the sigma x of the Rake Street divided by the sample size from the Rake Street. So the mean is given 3.6. And the sigma x for the Rake Street is what we want, which is the total ages of this 9 used cars. And there are 9 of them. All right. So can we find out the sigma x for this 9 used cars from the Rake Street? Yes. Okay, then we calculate out the value is going to be 32.4. Okay, hence, to find the mean of all 24 used cars, the formula is this. We have to look for the sum of ages of these 9 used cars from Rake Street, plus with the total ages of the 15 used car ages from the Fairview. So it's the Fairview. All right, divided by the total samples, which means the total number of the used car from Rake Street and the Fairview. Okay, so that is how we can calculate out the mean of all 24 cars. So this 32.4 found, and then is given by the questions 64 divided by the total Rake Street car got 9, the total Fairview car got 15. All right, so we calculate out, find out the mean, and we put it in the fraction form, 241 divided by 60. And we round off to 3 significant figures. It's going to be 4.02. So that means the mean age of all 24 cars is 4.02 years. Okay, now we continue to find out the standard deviation of the ages of all 24 cars. So same thing, in order to find out the standard deviation, first we must find out the sigma x squared. So for the Rake Street cars, let's say we take the standard deviation formula. standard deviation for the rate street. So it's going to be square root sigma x squared of the rate street divided by the number of used car from the rate street minus the mean from the rate street, right? Square. Okay, as given by the question, standard deviation from the rate street car is given 1.925 square root and sigma x squared for the rate street is what we need to determine here. And the number of used car from rate street is 9. And the mean also is given 3.6 and squared. All right, so do the calculations. Sigma x squared from rate street is going to be 1.925, need to be squared, and then sum up with 3.6 squared. And this whole thing is going to multiply with 9. All right, so just press calculator. We are getting 149.9906. Okay, once we have found the summation x squared, the sigma x squared for the rate street car, now we are able to find the standard deviations of all 24 used car. Okay, so according to the formula, we had sigma x squared for the rate street plus with the sigma x squared for the Fairview divided by the total number of cars for both. And then minus of the mean. So according to the formula, it should be this. Sigma x for rate street plus sigma x for Fairview divided by the total. Bracket square, right? So do we have the sigma x squared for rate street? We have found it, 149.9906. So do we have the sigma x squared for the Fairview? Is given by the questions, 352. And the total of them, of course, is 24, which is 9 used car from rate street and 15 used car from the Fairview. And as I mentioned, this is the mean. Right, so the mean we have found of all 24 cars, we calculated 4.02. But 4.02 is the round off figure. Then I prefer to take the exact value, the fractions for the mean, 241 divided by 60. Bracket, square, and we are going to square root the whole thing. Right, now we can press calculator and getting the standard deviation to be 2.19, round up to 3SF. Okay, so that is the standard deviations of all 24 used cars. But first, you must get the sigma x squared for the rate streets as you are given the standard deviation by the questions. Okay, so this is how we get to find the mean and standard deviation for combined sets of data. Okay, let's have a look at the next questions. So this is the questions from October, November 2013, variant 6.3, question 4. All right, do try to answer these questions by yourself. And that's all for this video. Please subscribe to the channel and like the video, and I see you in the next lesson. Bye-bye.
That's all for today's video. If you're interested in more genuine sharing by other geniuses, please subscribe to our channel and don't forget to turn on the notification bell, ding dong. Also, if you're struggling with one or two past year questions and the mark scheme just doesn't seem to help, Genie has got you covered. Feel free to let us know what question it is by filling in the Google form linked in the description below. GenieUs Hub will get genius teachers to fulfill your request for the solution. Genie will see you next time. Bye-bye.